Hello, everybody. So we are getting into Chapter 18 today, looking at 18.1, Part 1. The theme of Chapter 18 is finding the volume of solids. All right. But before we can get into actually finding the volume of solids, we need to be able to know how to find the area of simple shapes. All right. And that's kind of what this Part 1 is all about. We're going to be looking at finding the area of triangles and parallelograms. All right, so go ahead, get this title here. Don't forget the part one. Go ahead and get this first formula for the area of a rectangle or square, and then we'll keep going. Okay, so yeah, area of a rectangle or square. Just a little reminder, parallelograms. If you guys remember, there was a lot of different parallelograms we learned, and two of them were rectangles and squares, just as a little reminder. But to find the area of a rectangle or square, all we have to do is multiply the base of the shape times the height of the shape. Okay, so over here on this typical rectangle, we would just multiply the length of the base times the length of the height, and boom, we would have the area of our shape. Okay, one thing to just always keep in mind, the base and the height of a shape will always be at a 90-degree angle from one another. All right, and as these shapes get kind of, I guess, stranger looking, always looking for that 90-degree angle will help you find those two things. Okay, so let's keep moving and let's take a look at two other formulas. All right, this one is the generic formula for the area of any parallelogram. If you guys notice, it's the same thing, base times height. All right, and then we have the area of a triangle, 1/2 base times height. So go ahead and copy these two. Okay, so you guys can see on this generic parallelogram, which by the way, parallelogram are just opposite sides parallel. Our base and our height, again, we can find those by looking for that right angle. All right, and that's what we do, multiply those together and we'd be done. Okay, when it comes to a triangle, it's very similar, but the difference is it's 1/2 base times height. And again, the base and the height of a triangle will always be at a 90-degree angle. All right, you guys will just kind of see, depending on the shape of a triangle, sometimes the height will be shown inside of it. Sometimes, say I had a triangle like this, sometimes the height will be, outside of it. It really just depends on the shape of the triangle. And sometimes, just by the way, the shape or the height will be outside the triangle. If I had something like this, oh, that's terrible. Okay, if this was the base, they sometimes do a little dotted line and show you the height outside of the triangle. All right, so just again, when in doubt, look for that 90-degree angle. There's your base and your height. Okay, so yeah, basically this whole lesson is just us using these formulas. So let's try out a pretty typical problem. Go ahead and copy this one, and we're going to find the area of this triangle. Okay, so first things first, just recalling area of a triangle equals 1/2 base times height. All right, on this triangle, if you guys notice, there's quite a bit here. There's 4 different values. Question is which ones do we use? What is the base and what is the height? Well, if you kind of, been following the theme, it's all about finding that 90-degree angle. All right, and those 2 segments that make up that 90-degree angle will be your base and your height. All right, so those are my values I need to plug in. So area equals 1/2 base 21 times height 8. Okay, so going to our calculator here. So let's see, first we'll do 1/2, oops, not half, 1/2. All right, and then times, okay, here's a big thing. Notice how they put the multiplication dot in the denominator of my fraction. I don't want that. So I'm going to go back and I'm going to click next to the fraction and then do times, and I already forgot it because that's how my brain works, 21 times 8. All right, so times 21 times 8, and it looks like I'm getting 84. Okay, so there it is. Area is 84. And if you guys remember, when we were finding the area of circles, we always would do it as units squared. And it's the same thing here. If this was in inches, we would say 84 inches squared. But there are no units here, but I want you guys in your notes to just remind yourself that it would be units squared. Okay, and again, just a reminder, the area, it's the all of the inside of your shape. So, all the area of the inside of this, you can think of it as like if we had to lay tile on a ground that was this triangle shape, we'd have to lay 84, feet squared of tile or whatever the unit would happen to be. Okay, so let's try another one of these where we're looking at a parallelogram. Go ahead and copy this and we'll do it together. Okay, so reminder, area of any parallelogram, whether it's a square, rectangle, rhombus, whatever, is just base times height. Okay, again, I'm wondering what is the base and the height of this shape? And I first look at this 90-degree angle, and I notice that the two segments making that 90-degree angle are this one and this one. Okay, 17 would be the height. What is the base of this parallelogram? There's no number down here. Well, we just have to remember opposite sides of parallelograms are congruent. If this thing's 30 degrees, or not degrees, but 30, then this is 30. Okay, so there's my base and height. And notice I'm ignoring 20. It has nothing to do with the numbers I'm plugging in. Okay, that's really the only tricky part of these problems is just making sure you pick the right numbers. Okay, so the base of my parallelogram is 30. The height is 17. All right, going back to my calculator, 30 times 17. Looks like I'm getting 510. Okay, 510. And again, let's just point out it would be in units squared. Okay, so yeah, really, really easy formulas. But just make sure you're picking the right numbers. That's about it. Okay, so I'm gonna have you guys try out actually 3 of these problems together. So yeah, it looks like you're finding the area of this shape here. I'm gonna let you recall what this is called, named. So yeah, these 3 shapes, go ahead and copy them, and you're gonna be finding the area of each one. Number 3, if you guys recall, this is what we learned in the last chapter. So you might have to refer back to those notes to remember the formula for the area of a circle. Okay, so try these 3 out. All right, so on number 1, first thing, just to kind of recall, this is technically a square. If you guys remember, a square has 4 congruent sides, 4 right angles. So it's good to know. Okay, and that means it's a parallelogram, and we can use our formula, area equals base times height. Okay, the base and the height of my any shape is always at a 90-degree angle. So again, I would focus on probably, there's a lot of 90-degree angles, but I would probably consider this the base and this the height. Obviously, we know that this is 15. What's the base? And yeah, you guys can see they're all congruent. So this is also 15. All right, so area equals base 15 times height 15. And yeah, we can go ahead and type that in. So let's see. 15 times 15, I'm getting 225. Okay, let's again point out units squared. There it is. Okay, moving down here, it looks like we have a triangle, and you guys can see what's happening on this is they're showing us the height outside the triangle, okay, which is no big deal. We can still see, yep, 2 segments at a 90-degree angle. But yeah, let's recall the formula for the area of a circle. Area of a circle is 1/2 base times height. All right, so yeah, let's plug it in. Area equals 1/2. I would probably consider the base to be 15 and the height to be 9. By the way, I say probably consider because if this thing was flipped on its side, normally I consider the one on the bottom the base and the one going up the height. But if this thing was flipped on its side like this, I would probably consider 9 to be the base and 15 to be the height. All right. So it really doesn't matter which you plug in for which. It's just all about the orientation. Okay, so yeah, 1/2 15 times 9. Let's type it in. So 1/2, and then I'm going to click on it, and then times 15 times 9. Okay, here's something interesting. They're giving me a decimal, or not a decimal. They're not giving me a decimal on this. They're giving me a fraction. All right, so over here, let's see what happens when we click this. Okay, so that's actually interesting. I didn't know you could do that. So this is giving you the exact answer as a ratio or a fraction. If you click this, it'll give you the decimal form of it, which is, I think, what we want on these. So 67.5 is our area. So 67.5, again, let's point out units squared. Okay, last one here is finding the area of a circle. Hopefully you kind of memorized this while we were doing the last chapter. The area of a circle is pi r squared. Careful, you might have thought it was 2 pi r, but remember that's circumference of a circle, not area. All right, so pi r squared, and the only thing we got to plug into this is the radius. Be careful, they're not giving us radius on this, they're giving us the diameter. So we need to recall that the radius is half of that, 6. Okay, so pi 6 squared. All right, so let's type it in here. So let's see, pi, let me delete these, this is kind of getting a mess. Okay, so pi 6, and then the dedicated square button. Looks like we're getting 113.09. We're going to round to the tenths like we always do, so that 0 is going to round up to a 1. So 113.1. Okay, and again, units squared. Okay, so yeah, that's finding the area of these basic shapes. We got, I think, one more slide we're going to look at. We're going to try one more here where we're finding the area of another triangle. Go ahead and copy this. Okay, so triangle, we know first things first that the area of a triangle equals 1/2 base times height. All right, here's the thing I noticed. The base and the height are these two segments. This one I would probably consider the base, and this one the height. Here's the issue. We don't know what the base is. Okay, there's the bell. I'll wait for it. Okay, so we don't know what the base is. We need to figure it out. All right, so the question is how do we figure out what the base is? How do we find the missing side of this right triangle? Okay, well, we know the other two sides of the triangle. What theorem can we use to find the missing side of a right triangle? Okay, the Pythagorean theorem. All right, if you guys remember, the way I taught it was c squared equals a squared plus b squared. Good old Pythagorean theorem always shows up in geometry because everything is made up of triangles, or almost everything is made up of triangles. All right, so yeah, we can find our missing side. First thing, just remember your c value is your hypotenuse opposite your right angle. So I'm going to plug in 13 over here. All right, a and b are interchangeable. I'm going to make 5a, and we're going to call our missing side b. All right, so yeah, we just need to solve this thing for b. So I'm gonna, I guess let's square these numbers first. So 13 squared is 169, 5 squared is 25, plus b squared. Okay, and then from here we can subtract 25 from both sides. Okay, so 169 minus 25. Whoa. All right, looks like we're getting 144. All right, just be careful. That's what b squared equals, right? We're getting 144 equals b squared. Now to solve for b, we need to undo squaring with square rooting. So when you take the square root of 144, just kind of a little reminder, in this thing, when we go to do this, we would click on the next line, hit square root, and then to enter that exact answer, instead of typing it out, say this was a really weird decimal, remember, you can just hit that answer key, and it plugs it right in. Okay, so square root of 144, 12. Okay, so we just figured out that our missing side, I'm going to flip it around, b equals 12. Yep, and now that we know that, we can show, okay, there's our missing side length. Now we can find the area of this triangle by doing 1/2 base times height. So be careful, we're not done here. But last step, plugging in those numbers. The base we just figured out is 12. The height is 5. By the way, you can probably do this stuff like in your head. If you can take half of a number, half of 12 is 6. 6 times 5 is 30. You can do a lot of this in your head. And again, units squared. Okay, cool. So yeah, that's finding the area of basic shapes as we go through this upcoming chapter and also the next chapter. knowing how to find the area of these shapes is important. And you guys saw it. This is really simple stuff. But the next section, we're going to be getting to actually finding the volume of solids, of 3D polygons. All right, so I'll see you guys then.